Hey, what's going on? Welcome to my video. Today I'll be talking about balancing equations and the law of conservation of mass and how they go hand in hand with each other. So a balanced equation represents the amount of atoms of each element that's present. It also obeys the law of conservation of mass, which states that all amount of matter remains constant within the chemical reaction. The law of conservation of mass also states that mass can neither be created or destroyed. So why is it important to have a balanced chemical equation? It's important to have a balanced chemical equation because one, we want to obey the law of conservation of mass. We can also derive more information from a balanced equation than from an unbalanced equation. For example, when we're doing stoichiometry, we are able to find out the exact and true calculation of how many of each reactant has reacted in grams and moles. And also, we want to have a balanced chemical equation to have the right chemical product. All right, so let's go ahead and take the water molecule for example. I'll have it in my product as H2O, and in the reactant, I'll have H plus O. Right then and there, you could see that it is unbalanced because there's two hydrogens on this side and then one hydrogen on this side, along with one oxygen and one oxygen. Well, that's the balanced part. But now, what you need to do is add a coefficient. So we add a 2 in front of the H, balancing out to H2O. What we want to do is, or what we don't want to do is, we never want to change the subscript. We don't want to change the subscript because it changes out the whole molecule. For example, let's take the molecule of glucose, which is C6H12 and O6. If we change one of the subscripts, let's say the hydrogen to 9, then it's no longer glucose. And that's not what we're going for. We want to keep the same chemical or the same amount of atoms within the chemical reaction. That also obeys the law of conservation of mass. So let's go back to the water molecule. I have H2O here as my product, and then as in my reactants, I have OH, O plus H. If we keep it O plus H throughout the whole chemical reaction, it's no longer going to equal H2O, but it's going to equal hydroxide, which is not what we're going for here. We want the product as H2O. Well, there you have it. You have a balanced equation now. 2 hydrogens here, 1 oxygen in the reactant, 2 hydrogens and 1 oxygen in the products. And the way you check is you simply just calculate or count how many atom of the elements there are. 2 hydrogens and 1 oxygen, which comes out to 3. And on this side, it should come out to 3 as well. And it also still obeys the law of conservation of mass, which states that all amounts of matter remain constant during the chemical reaction. And also, one thing in mind is that, change the coefficients, not the subscripts. And remember, balancing an equation can help out along the ways of stoichiometry, and also it just gives you more info than an unbalanced equation. And there you have it. See you next time.